So spectral reflectance curves, I have already introduced in the previous class what are the spectral reflectance curves. So electromagnetic energy incident on the surface features and partially reflected, absorbed and transmitted through it. So reflected, this reflection varies with the energy, amount of energy and type of object, variety of object. So based on that, we will go through some common features like vegetation, soil, and water. Okay, these are three common features. Their reflectance we will study. Okay, so you all know that vegetations appear green. Okay, why vegetations appear green? Yes, so vegetations have chlorophyll, and chlorophylls reflect more the green color and absorbs the red and blue from the RGB basic colors. So the reflectance should be high in green in the visible region. Now we are considering the whole electromagnetic spectrum. So in the visible region, that is 400 to 700 nanometer. Okay, the reflectance should be high in green color in visible region. So here you can see the reflectance at green color, it is high. Okay, this depends on different type of trees. This is deciduous trees, grass, aquatic plants, and coniferous. Okay, so here you can see here 0.5 to 0.6 micrometer. So somehow here is green band and blue band, red band. This is NIR band. Okay, near infrared band. So what happens in green color? It shows highest reflectance. So you can see the peak in green color, but the highest reflectance is showing in what? Near infrared. Why? Because in near infrared, what happens? This infrared, near infrared, it gets below the chlorophyll. Okay, it gets below the chlorophyll and it reaches the mesophyll. Okay, it gets below the chlorophyll and reaches the mesophyll. And its mesophyll, what happens? This red, green, blue, this RGB are all are absorbed. All colors are absorbed. Okay, all colors are absorbed. So when it reflects back, sorry, this green and blue are absorbed, and when it reflects back, the red color appears more. Okay. Infrared, that is red color, appears more. So that's why the reflectance is very high in red color. Okay. So here you can see the infrared radiation penetrates the palisade cells and reaches the irregularly packed mesophyll cells, which make up the body of the leaf. Mesophyll cells reflect almost 60% of the NIR radiation. Okay, almost 60% of the NIR radiation is reflected back. Most of the remaining energy is transmitted. Since absorption in this spectral region is minimal, healthy vegetation therefore show brighter response in NIR region. Brighter response in NIR region means red color. Okay, that means it's red color. So, so when you see a remotely sensed image, okay, remotely sensed image, you can see that red color is allotted for vegetations. So in false color composition, FCC. Okay, FCC will study later what is FCC, what is false color composition. So what basically I am telling you in short, what basically we do, we associate some colors like RGB. So we give green color to red, we give blue color to green, we give red color to blue. Okay, this type of thing we do to identify and to precisely identify the things. Okay, so that is the basic thing I have told you what is false color composition. So so what you have seen, the vegetations reflect most of the energy in near infrared region. Okay, this is the whole theme. Okay, So here you can see the absorption bands. The absorption greatly reduces and reflects increase in red infrared boundary near 0.7. So here you can see 0.7, it is exponentially increasing. The reflectance is exponentially increasing. The reflectance is nearly constant from 0.7 to 0.13. So here it is constant. Okay. The values in the visible portion in the spectrum are due to the, so here why these values are appearing, why these values are appearing, due to absorption in blue and red colors are absorbed, this is not reflected back. Okay, so on the other hand, reflection peaks for the green color, we have already discussed that. In the range from 0.7 to 1.3 micrometer, a plant leaf reflects about 50% of the energy. Here's, that's why it is showing constant reflectance pattern. Okay, we're getting it, all are getting it. Huh? So here, if we will go, so here you can see in this reflectance curve that there are different type of vegetations. One is deciduous, one is grass, one is aquatic, one is coniferous. So why this why this variation is occurring? Why this variation is occurring? Okay, can you say why this variation is occurring? Hmm? Health of the tree, that is stressed vegetation. It is variety of vegetation. Deciduous tree, grass. Grass are below the surface. These trees are widely distributed. Okay, aquatic. These are inside the water. Conifers. Conifers. Which plants are conifers? Yes. Pine tree. Okay, pine trees. Yeah. So pine trees are conifers. So why this type of reflectance curve which we are observing? Deciduous tree, why it is showing very highly reflectance in NIR and relatively less in grass? Anyone?
It's higher than the grass.
Higher than the grass.
And the leaves are totally green.
Then aquatic should be less than coniferous. Yes, exactly. Different type of leaves they have. Very good, Ankita. Different types of leaves. Okay. No angle of reflection is not there. Different type of leaves. Basically, the chlorophyll thing is different in this context. Okay, in these vegetations. Okay, that's why this variation is occurring. Aquatic plants, they will be inside the water, so they will, water will also absorb the incidental energy. So aquatic plants will have small amount of energy to absorb. Okay, like that conifers plant are snow only covered in the snow. Okay, so that's why this variation is occurring. So here you can see this is a curve of healthy vegetation and this is a curve of stressed vegetation. Stressed vegetation means a vegetation that is like not getting sufficient amount of nutrient. Okay, it is destroying. Okay, okay, dying out. So you can see the chlorophylls. The chlorophylls will be higher in this healthy vegetation and chlorophylls will be lower in stressed vegetation. Like that, mesophylls also higher in healthy vegetation, lower in stressed vegetation. So that's why the variation occurs. Okay, I will show you uh, one example. Okay, wait. Not now. Let me download and I'll show you at last. Okay, so these are the things. Now see, dips in reflectance occur in 1.4, 1.9, 2.7 micrometer. Why? Because of water, because of presence of water in the leaves. So these are called as water absorption bands. What happens? when you will plot the reflectance, you will observe certain dip. Okay, again rise. Okay, again rise in reflectance. Because of this, these are water absorption bands. What happens? The incidental energy is absorbed by the water present in the leaves. Okay. Next is spectral reflectance of soil. So spectral reflectance of soil depends upon various things like moisture content, soil texture, okay, proportion of sand, silt, clay, surface roughness, presence of iron oxide and organic matter. These are the things based on which the reflectance varies. Okay, so one by one we can see the presence of moisture in soil decreases its reflectance. As you know, water absorbs the electromagnetic energy. Okay, the presence of moisture in soil decreases its reflectance. As with vegetation, in these bands 1.4, 1.9 and 2.7 micrometer, these are water absorption bands. Okay, so can you tell a clayey soil will show higher reflectance or a dry soil will show higher reflectance? Dry soil will show higher reflectance. Okay, so if we plot here for a dry soil and for a clay soil, then this will be for dry and this will be for clay. Okay. So next is similar absorption characteristics are displayed by the clay soils. Clay soils have hydroxyl ions absorption at 1.4 and 2.2. Soil moisture content strongly related to soil texture. Yes. So here you have to mark coarse sandy soils are usually well drained. Coarse sandy soils. The soils in which the grains are very coarse. So the water does not become trapped in the soil. So they are generally dried in nature. So they will show higher reflectance. Okay. On the other hand, if you will see the finer grains will be not well dried. Okay, so they will show lower reflectance. Okay, but if we are considering only dried version, okay, if we are considering only dried version, we'll see coarse and fine grain, then see. On the other hand, poorly drained fine texture soils have lower reflectance, okay. In the absence of water, see. In the absence of water, the soil itself exhibits the reversed energy. That is, coarse texture soils appear darker. If you are considering water, then the coarse grains will show higher reflectance. Okay, well drained coarse grain, and the fine grain will show lower reflectance. But there, if you are considering there is no water in the soil, then the coarse grain will appear darker. Okay, if water is there, then well drained coarse grain will be darker. If water is not there, coarse grain will be surface area is not more in coarse grain, na? How surface area is more in coarse grain? Huh? Yes, voids are there. Surface area is more in fine grains. Okay. If you are considering water is present in the soil, then the coarser grains generally what happens? They cannot absorb much of water. They generally drain the water because of the presence of voids. Okay, so they will appear lighter, but the finer grains they will absorb water because the permeability is not high in but for finer grains, so they will appear darker. But in case of purely dried soil, there is no water, then coarse grain will appear darker and fine grain will appear lighter because of presence of more surface area. Okay. So two other factors that reduce the soil reflectance. There are surface roughness. Surface roughness, you know, diffusive reflection and specular reflection. Okay. The more the rock surface, that will more diffusive reflection, and more the diffusive reflection, less the energy you will get. Okay. And the content of organic matter, more the content of organic matter, less will be the reflectance. Presence of iron oxide in a soil also significantly decreases reflectance. Okay, these things you have to write 5-mark question or 10-mark questions. This is spectral reflectance of soil. Everyone getting it? Next we'll go spectral reflectance of water. Okay, spectral reflectance of water. So again, this spectral reflectance of water depends on various things. Like the water is shallow water or deep water. How much of nutrient content is there? How much of vegetation is available in this water? How much of oxygen? What is the pH? These all things vary. The salinity also. Everything is related to this reflectance. Reflectance will vary based on that. We are measuring the pH and salinity of the ocean water by remote sensing. We are measuring that based on this reflectance data only. Okay. So based on that, we are telling that how much nutrient is present in which position. So the fisherman should go there. They will get much of fishes there. Okay. So, spectral reflectance of water varies with its physical condition. In the solid phase, what will happen in the solid phase? The reflectance will be higher because snow shows higher reflectance. So, in the solid phase, it will show higher reflectance. In the liquid phase, it will show lower reflectance. Okay. Water in the liquid form shows higher reflectance in the visible region between 0.4 to 0.6 micrometer. So here you can see between 0.4 to 0.6, that is visible region. 0.4 to 0.7 is the visible. Okay. 0.4 to 0. If we will consider 0.4 to 0.6, water shows highest reflectance. That means water shows its highest reflectance in 0.4 to 0.6 micrometer range. Okay. 0.7 micrometer are completely absorbed. 0.7 micrometer, which wavelength? Red. So red is completely absorbed. That's why water appears blue. Okay. So, but in over 0.6, everything is absorbed. So that's why in NIR image, near infrared image, water appears dark, pure dark. Vegetation appears green, red. Okay, water appears dark. Okay. So if you will see one list for image, like resource chart image, you can see there the rivers are darker. Okay. So next, it is also yes. So water reflectance is also related to presence of suspended matter. So what will happen? Reflectance will increase with suspended matter or decrease? Hmm. Decrease or increase? Why increase? Why decrease? Yes, exactly. Water, the property of water is it absorbs almost all electromagnetic energy. So if there are some suspended particles, it will reflect back. So if there are suspended particles, the water reflectance will be more than that of pure water. Okay. Like that, can you see shallow water will show darker or deep water will see darker? Deep water, because it will absorb all the magnetic electromagnetic energy. Shallow water will reflect some back. Okay. High transmittance typifies these wavelengths with a maximum with blue-green portion of the spectrum. Already we have told that 0.4 to 0.6. Okay, blue-green spectrum. Water bodies containing large quantity of suspended sediment normally have much higher visible reflectance. Okay. Likewise, the reflectance of water changes with chlorophyll. Chlorophyll content, how much of vegetation is there? Okay. Increase in chlorophyll concentration tend to decrease reflectance in blue wavelengths and increase in reflectance in green wavelength. because chlorophylls are there. So water will appear more greener. Many important characteristics of water such as dissolved oxygen concentration, dissolved oxygen concentration, pH, salt concentration cannot be observed directly through changes in water reflectance, but we are now getting it. Okay, in hyperspectral data we are getting it. Green दिखेगा ना, it will appear green. In coastal regions, it shows green. It shows yellow. They may be dried vegetation, like they may be like exposed to much of the sun rays. But generally, you see everywhere there is greenery or there is algae. You can see greener composition of water. Generally, coastal water, what happens? Generally, coastal water, the high tide, low tide composition is there. When high tide goes, the algae gets healthier. Okay. When low tide comes, they get dried. If will they get dried, the chlorophyll amount will less, so they will appear yellow. Okay. So yellow trees, they cannot survive. Yellow trees, how they will survive? How they will make their food? Yes, that's why after ripening the leaf, it gets detached from the tree. No? Okay, so these are the spectral reflectance curves of water, soil, and this your vegetation. Okay, anyone having any doubts? Features of the remote sensing satellites in the world. The majority of remote sensing satellites we use is Landsat. Okay, Landsat. India uses IRS. Also, Landsat also uses Spot and now Sentinel 2. Sentinel 2. Okay, so this we will not study. This is not in our course. These three are in our course. Landsat is from USGS and NASA. Okay. IRS is from ISRO and Spot is from France. Okay. So see how their geological survey, how USGS is doing. They have their own satellites, and see our GSI. Okay. Uh-huh. So, so first we will go to Landsat. So basically, Landsat is the longest running program. Okay, oldest, not, we cannot tell it is oldest, but it is the longest running program. It is still running. Okay, Landsat 9 is the latest satellite in 27 September 2021. Okay, this one. Okay, recent satellite launch Landsat 9. So Landsat is a totally consist of 8 satellites. Okay, because 6 failed. Landsat 6 failed. Otherwise, it is 9. It is of 9 satellites, but Landsat site 6 failed. So now it is of 8 satellites. The recent one is Landsat 9, launched in 2021. Because the age of satellites is less, like 4 years, 5 years, 6 years, 7 years, depending on their battery. Okay, that when these satellites go to the darker zone, they use their battery power. So this battery power has certain lifetime. Your mobile battery has certain lifetime. After that, it gets dead. Okay, in your Mars mission. Okay, the satellite was made to study only 8 months, but it worked for 4 years. It worked for 4 years. Mangalyaan. Okay. So likewise, this Landsat 1 lifetime. This is the Landsat 1 lifetime. Landsat 2, Landsat 3, Landsat 4, Landsat 5. Okay, Landsat 6 play failed. This is Landsat 7, 8, 9. These are working. Landsat 7, 8, 9. These are now working. Okay. So the first it was named as Earth Resources Technology Satellites. Later it was named as Landsat. Like our IRS. IRS now we are not using IRS. We are using Resource Sat. Okay. So the mission consists of 8 satellites. So here you can see the 8 satellites. 1, 2, 3, 4, 5, 6, 7, 8. The Landsat 9 data is not here. Okay. So almost same. Landsat 9 is almost same. I'll tell you. So the altitude is see 970 kilometer for 1, 2, 3. For 1, 2, 3, this table you can remember easily. Okay. For Landsat 1, 2, 3, the altitude is 970 kilometers. This is required for long question writing. I am telling you, not for short question. Okay. The altitude is 970, and from 4 to 9, the altitude is 705 kilometers. Okay. Polar satellite, these are polar satellite. Remote sensing satellite means polar satellites. Inclination is 99 degree, 99.2 degree, and 45 to 98.2 degree. Okay. Equatorial crossing 9:30 a.m. How much time it crosses the equator? Okay, equatorial crossing. Period, orbital period. Okay, orbital period. That is pole to pole, 103 minutes. Okay. Number of orbits per day, 14 orbits. Per day, they encircle 14 times pole to pole. Repeat cycle is 18 and swath is 185. Okay, swath is 185. So these are the specifications of Landsat. So here you can see also the time range from how much it is working. Okay, let's say 7, 8, 9 it is working now. So if you want to see Landsat data, I can show you. Scanners used in Landsat. First of all, you can see Landsat 1 to 5. There is a scanner named MSS, multispectral scanner. Okay, multispectral scanner have 4 bands. Okay, green band, red band, NIR band, NIR band. 2 NIR bands are there, and green band and red band is there. So here blue band is not there. So you cannot get the visible spectrum like view from this data, like our list 4. Our list 4 resource chart, India's sensor, there also you cannot get visible thing like data. Okay, so this is multispectral scanner. Next is thematic mapper Landsat 4 to 5. These thematic mapper is used in Landsat 4 and 5. So here 3, 4, 5, 6, 7 bands are there. Blue, green RGB, near infrared, SWIR band, thermal and SWIR 2. Okay, these bunch of bands are there. Then Landsat 7 में क्या हुआ है enhanced thematic mapper. This is thematic mapper. Only 2 sensors are extra. That is sorry, 1 sensor is extra. That is panchromatic. That is panchromatic. Always panchromatic resolution is very high. Always. Okay, that is enhanced thematic mapper. Then this is operational land imager only and thermal infrared sensor TIRS. Okay, these are having 11 sensors. See, these are having 8 sensors. These are 11 sensors. Before that, it is 7 sensors. Okay, here you can see blue, green, red, NIR, SWIR 1, SWIR 2, panchromatic. These 8 bands are same. Okay, then here you can see Cyrus band is extra there, thermal 1, thermal 2. Then the uses of Landsat here written the uses of Landsat. Okay, flood mitigation, agricultural commodity, water flow, habitat, coastal changes, forest health monitoring, every kind of environmental applications. Next, we are going to IRS, Indian Remote Sensing. So, Indian Remote Sensing consists of a wide range of satellite like Resource Sat, IRS, Cartosat, okay, EOS, Earth Observation Satellite, EOS. They are also called as RISAT, okay, radar sat. RESAT also called, US is also called as RESAT. Ocean SAT. Okay, these are also all are included in Indian remote sensing program. Okay, so basically our main sensors are list 4 now. Now it is list 4. Okay, list 4. It is not written here. List 4. So Indian remote sensing satellite, it started with 1988 IRS-1A 1988. Okay, sun synchronous near polar orbit. So here you can see the specifications of IRS-1A, 1B, 1C, IRS-1D, IRS-P2. Now Cartosat 2 is in working condition, Risosat 2 is in working condition, and latest is Risosat 2A, that is also in working condition. These are not in working condition. Okay. So IRS-P2 is also in working condition. So orbit is sun synchronous, equatorial crossing 1030. Now we can see the altitude. Okay, inclination here written, everything. Sensors, here you can see the sensors. Okay, based on from which list 3, list 4, AWIFS, these are our important sensors. These are where these sensors now we are using for remote sensing. Okay, so here you can see the list 4. These are working in which band? Anyone? This one, this one, this one. Name the bands. This is near infrared. This is visible, but the red band is not here. This is blue and green. Blue and green band. Red band is not here. Okay. So this is list 4. These are list 1, list 2, list 3. AWIFS sensor is there. Now it is a sport satellite. Sport satellite is from France. Système pour observation de la Terre. Okay, de la Terre. It means observation of Earth. Huh? It means observation of Earth. System for observation of Earth. It means okay, de la Terre. By the Centres National d'Etudes Spatiales (CNES), France, as a commercially oriented Earth observation program. Okay, first started February 1986. This is the first observation satellite that used a linear array of sensors that the push broom scanning technique. Also, these were the first system to have pointable and steerable optics, enabling side to side of nadir viewing capacity. Means this is nadir. This can also see here. This can also see here. Okay. This is spot. So list of satellites, Spot 1 to Spot 7. Spot 7 is recently launched, March 17, 2023. So we have data from Spot 1 to Spot 6. I have not have tracked that. So these are the sensors. These are the altitude, inclination, period. Okay. So these are the sensors, main sensors. Spot 1, 2, 3 carried high resolution visible, means spot is totally visible in visible spectrum. Spot works in visible spectrum. Spot for high resolution visible and infrared. Okay. Spot 5 is high resolution geometric instrument and high resolution stereoscopic instrument. Stereoscopic instrument, that there we can get DEM, digital elevation model. That means height and elevation data also we can get. Stereoscopic. Okay, Spot 6 includes new AstroSat optical modular instrument. Now these are the sensors. Huh? You can see here what are the bands in these sensors. HRVIR, this VI, HRG, HRS and VI. You can see what are the bands are used in this data. Okay, so this much for remote sensing. For prelims, after that digital image processing, aerial photography. Aerial photography, I think little I should say. No, Spot is commercial, like it sells its data.